the best, number one and nothing less. Lead me to my destiny. I have waited patiently. I have vision, though I believe. I know I can count on me. So stand up for the champions, for the champions. Stand up, stand up.
Hello everyone, you're welcome to Biology Video Lectures with Akerele Oladimiji Philip. On this edition of the video, we're looking at past questions in JAMB, now called UTME. And what we'll be doing is that each year we'll solve it in 5 parts. That means 10 questions per part. That means we have 5 questions in biology for JAMB. So what we'll do is each video contains 10 questions. All right, so let's get started. The gallbladder of a mammal has a duct connected to what? To the duodenum. All right. Now, what you need to know, please pardon me. What you need to know is that the gallbladder contains bile. All right, bile. What's the function of bile? Bile is for emulsification of fat. So what you know is that the gallbladder is connected to the duodenum using a duct called bile duct. So bile duct will empty bile, which is a secretion, into the duodenum, which is the first segment of what? Of the small intestine. So that is the answer. Duodenum. Now, number 2, the opening of the stoma, that's the singular of stomata, is controlled by what? Presence of Now, the opening of the stoma is controlled by the presence of what? Now, what you need to understand is that stoma is the plural of is the singular of stomata. Stomata looks somewhat like this. Okay, let me explain what I'm saying better. These two are called guard cell. Now, this guard cell, this hole here is called stoma. Now, when this guy, how it operates is that when there's high solute here, it will suck in water by what? Osmosis. When it's sucking water, it swells up, then it opens. So the opening of stoma is controlled by the presence of guard cell, no. Decrease in solute, no. Increase in solute, I just told you here now, from what I just showed you, that when there's plenty increase in solute here, it will cause water to what? To flow in by osmosis. Then when that happens, it will stretch. Then this place will open. So the answer to that question is C, which is increase in solute concentration in the guard cell. All right. Now use the diagram below to answer question 3 and 4. Now you can see here that this is a beaker. Sorry for the print, it's not clear. No, this is hollowed yam tuber. This is water, this is beaker, this is salt solution. Please take note of this, that the salt solution is in the beaker, while while water is inside the what? Yam. So what they want to prove to us here is osmosis. And osmosis is the movement of water from area of, or you can say solvents, from area of lower concentration to area of what? Higher concentration. So what it means is that water will move from this region of lower concentration to what? Higher concentration. So water will move from here to here. All right. So I don't know the question behind on it, of course, but I'm just trying to explain it to you. So now yam used in this setup is because it is what? It acts as a semi-permeable membrane. So the answer is A. Now, what's the meaning of semi-permeable membrane? It means a membrane that does not allow solute and solvent to pass. Rather, it only allow what? Solvent alone to pass. That's what it's called, semi-permeable. All right. Now, number 4. Which of the following result is to be expected if the setup is left for several hours? Watch. Movement of water from the salt solution, no. Decrease in size of the yam, no. Movement of salt solution into the water, no. Decrease in the volume of water inside the yam, yes. I just told you now, yes, because this one here will suck in, we attract water. Like I told, if you have seen my video on cell and its environment, so I said there that where the higher concentration will always be sucking water to dilute itself, all right, so that's why water is moving from here to here. Now this is against the normal thing you know in your textbooks. In the textbook, what they normally put the experiment is having the source solution here and water here, but of course this is JAMB, you need to understand. So that's why we are out to make you understand, not just to cram the answers, all right. Now number 5, which of the the eggs of birds contain relatively larger amount of yolk than those of amphibians and reptiles? Because why? Let's get to see that now. Embryo development is longer in birds. No. They lay shelled egg. Birds generally have bigger size. I'm trying to get that. Give me a minute. Yes, the answer is B. Birds lay shelled egg. Now what do I mean? Look at this. For amphibia, their eggs don't even have shell at all, so their embryo inside the egg can easily carry out gaseous exchange. Now for basically for reptiles, they have leathery shell in their egg, and that leathery shell allows gaseous exchange to take place in their own egg. But for birds, their eggs are shelled. No gaseous exchange is easy like that, so the amount of yolk will help to sustain the egg alive. So it's like the more the yolk, the more the energy, the more the provision for it to stay alive. But for these two, their eggs can still interact with the outer world than the egg of birds. So the egg of birds, since their own egg has shell and it does not interact easily with the outside world, so it needs something to keep it alive, which is yolk. And the more yolk we have, the more for it to have to have better life, gaseous exchange, food is stored in the yolk and all that to feed the embryo. Then number 6, in the internal structure of plant, a wide pith in the center is common to what? Now in the internal structure of a root, not root, it's only root. Let me quickly say that now. For a monocot, let me quickly draw that quickly now. This is a root here. Now what you can see here is the cross section. It's rough though, but it can carry out the message I want to pass. This is the dicot root, this is monocot root, this is dicot stem, this is monocot stem. So the question says that in the internal structure of a plant, a wide pith is in the center, or in the center is common to what? Looking at this diagram, you can see this place is called pith. This is called pith. This is not a pith. This is not a pith. So what we say is this. So this dicot root, where it's supposed to have pith, what we have is there is xylem and phloem. For monocot root, this is monocot root, we have pith at the middle. For dicot stem, there's pith at the middle. These are xylem and phloem to form a ring. For monocot, what you have is scattered vascular body, which is xylem and phloem. So the answer to our question will be what? Monocot root and dicot stem. So let's see if you can see that in the question. So dicot root and monocot stem. No, dicot stem and monocot root. There should be dicot stem and monocot root. We just explain that. All right, hope that is clear. So moving on, if a nursing mother is not producing enough milk, our hormonal system is probably deficient in what? In prolactin. Prolactin is the hormone that produces milk inside the breast, but the hormone that causes milk to come out of the breast is called oxytocin. Please pay attention. Prolactin is the manufacturing or synthesis, but the release is oxytocin. That is very important. Question 8. The type of joint between adjacent bones in the part labeled 2 is what? So this is 2. This, if you can look at this carefully, this should be your cervical, thoracic, lumbar, sacral, caudal. So this is a sacral. The kind of joint you have there will be what? Sliding joint. all right. The bones does not move, just move over each other gradually, all right. So number 9, the bone labeled 2 again, what is it called? It's called the what? Sacral vertebrae. I already explained that when I was mentioning that. The breakdown of fat and oil into simple absorbable compound is catalyzed by a group of enzyme called what? Called lipase, because lipase works on what? On fat or oil. Peptidase works on peptides, a type of protein. Amylase work on carbohydrates. Hydrolysis simply means it breaks the bonds, hydrogen bonds between let's say carbon and hydrogen and the likes. So this one does not really, or I can say breaking water bonds majorly. So this one does not really explain a specific job. All right, so that's the answer. So the next question we'll be saying is 11 to 20. Thank you.